Today we're going to work with characters a little bit. Character strings are treated like arrays. So if I picked out character 5, 6, 7, and 8, I ought to pick out long. So A of 5 colon 8. Oh, lights. Good, good. There we go.
I was going to say, you get the space.
Ooh.
It should be
6 through 9? No, it's 5. 5, 6, 7. Oh, good, good. Thank you. Thank you. Yes, indeed. It's counting the space as 5. So you're right. Absolutely right. You're going to do fine on the exam. you're going to be the person who does well in the exam. So, it's just a random string. Peace and long life, live long and prosper. Yes, which is LIVE space is 1, 2, 3, 4, 5. Long starts at 6. I miscounted the first time, as Martin picked out. Long starts at 6, so 6, 7, 8, 9 are long. If I add 4 more, if I go to 13, I'll get and. So long and. So you pick out character strings this way. You can create character strings. You can add oops, matrix dimensions must agree. I just realized I have to use concatenation. B is peace and long life. Cat. It should concatenate. Basically, concatenation adds one array to another array, and since characters are treated as arrays, I need to use cat. When I try to add arrays, it didn't let me. It gave me an error. Okay. I might be able to use the period operator. I'm not quite sure. Let's try it. It doesn't like it that way, so I need to use cat. Oops. Okay.
Put a dot within the cat.
Well, what's that now? What's that now? Oh, Oh, I know what I did wrong. String cat. STR cat. Okay. Easy. Oops, you're right. I just capitalized it. Don't want to capitalize. Oh, I got the caps locks on. Somehow I hit the caps locks accidentally. There. There we go. String STR cat. I cannot add. I cannot use a period add. I cannot use the ordinary cat, which I expected to be able to do. I had to go all the way to string cat. So we figured out how to pick out a piece of a string. We figured out how to add strings together. You can take numbers to strings, by the way. Chapter 3.3.1, actually. Number to string of pi. And of course, it puts it out in the format. Let's see. It's not a, it automatically converts it. Oh, I know what it did. I know what it did. It didn't take pi times 5. It took the value of the character, first character times 5, times you've got 1, 2, 3, 4, 5. You've got 6 characters. You'll notice it treats each character as as an element in a matrix. So 3 is element 1, period is element 2, and so forth. So when you take that answer, you've got a string now, and you're multiplying it times 5. Um, you're basically going to do 5 times whatever that character code is. Remember, characters have a code. Um, there we go. So these are the character code for 3 should be 51, for period should be 46, for 4 should be 49, 1. Uh, okay, something's lying to me. Right? Anyway, don't worry about it. It's weird. You got a string. That's the headline. You got a string. I did a number to string on this number, and now I can concatenate this string, number to string. See, oops, let's do it that way. Let's go up. There. Okay. So, okay, I'm going to concatenate all these strings together. Oops. Concatenate. Right. You're jamming them like a railroad train, one after the other. String cat. Cat just concatenates the matrices together. Just jams numeric matrices together. String cat jams strings together. By the way, you'll notice something that when you do this, it strips the space. So the blank doesn't show up, just the comma. There's other ways you got to insert space another way. And that's, um, I'm trying to go fast, so I gotta watch out for that. Not spend a lot of time on that. Okay. Um, Now you can. By the way, you guys have figured out display and type, DISP of a matrix. Okay. Type of a function. Let's see, trig. And I forgot the parentheses on the file, or the apostrophe on the file name. So type lets you, when you're using publish, type lets you display the output of a function, one of your files. Type file name, and it just spits out whatever's in that file. Display matrix spits out whatever's in that matrix. It spits out numeric matrices, or it spits out string matrices. By the way, another way you know that this 3.1416 is a string is right over here. And it tells you it's ABC. It's a string. It's characters. Okie dokie. So eval. The eval function. Oh, let's make x equals 5. Oops. This is useful for building. If you have a string that's doing something, you can remember that number to string. There's a homework problem where you have to save a bunch of figures, figure 1, figure 2, figure 3, and so forth. So you can do string cat figure, comma, number to string, comma, whatever the number is. And so you're going to create a file name. Well, here, this eval function lets you actually execute the file name or whatever is in the string. Evaluate whatever's in the string. So you could do a save or a load or file manipulations. So save figure 1, save figure 2, and so forth. So you can manipulate strings. You can create. Now, once you have this string, how do I execute this string? Well, the eval function is what lets you execute the string. Okay. In 3.5, there is something called inline functions. I'll just let you read about that. We've already talked about anonymous functions in Chapter 2, which is also in 3.5. We've also talked a lot about built-in functions. That's 3.6. That's built-in functions like sine, arctangent. We've gone through a lot of that already, so I'm not going to do that too much. Saving data, but this is kind of important. Magic matrix. By the way, matrix manipulations. We talked about that the last period about several matrix functions. Magic matrices are matrices where if you add everything up, I think it's also diagonally. You add up all the rows, you add up all the columns, they come out to the same value. It's almost like random. It's just a special kind of matrix. So I'm just generating a matrix with a bunch of values. That's all I'm doing. I don't think so. Magic matrices have to be square. Right. No. Okay.
How did we come up with those numbers? Is this just random or what?
Well, they have to add up. Magic matrices, if you add them up, the sum of each row has to be the same. The sum of each column has to be the same. So, and there's several kinds. You can obviously swap two columns or something like that, and you still get a magic matrix. So they're just special matrices. That's all. And the way they generate them, I don't know, and I don't care. To show you how to work with things, like saving a matrix. That's the point of this right now. So, oh, so it's going to. I've just saved the matrix A. Here's the file it creates. Just save matrix name. Boom. The purpose of this is when I close Matlab and I reopen it, the matrix won't be lost. It's in a file. I can load it back up. Let's see. Oops, wrong. I'm in the wrong window. I think I can do save all, but I'm double checking my help system just to make sure I can. So it just saves everything in memory. There we go. Save file name. You can specify the file name. I think if I just hit save without anything, that will save everything in the right. Now I can just clear all. You can. I don't have to. Okay. I'm going to clear all my variables because all my variables are over here. I can then just double click this. Right click load, and it loads them back up. Or, and then you'll notice when I right click load over here that it generates the Matlab command to actually load them up. So you can load it up using the Matlab command, or you can, I thought double clicking would work, it didn't. Right click. I can also, anyway, there's lots of things to do. Create a zip file, etc., etc. Lots of things you can do. So those are the .mat files, Matlab data, MAT. Instead of a DAT file, it's a MAT file. You guys have seen command history. You can literally save it. You can select all, and then you can save it, and you can create a where I think it's I have to right click to actually edit it. There we go. So a good way to save it is just to create a script. So you've selected it all, you've created a script. Now all the commands that you've ever done are saved. There's something called diary too. So you can do diary, diary on, diary off, and it lets you, it just records your diary to, um, it records your commands to a diary file. Let's go ahead and do that. So I turn it on, and then I'm going to save everything, and you'll notice it tells me what it's saving to. I'm going to load. Um, oh, I think it's there. We go. So I can do clear all the variables, which is just I had to double check um, that when I removes all the variables from the workspace. I just want to remove variables. I don't want to remove anything else, so I had to be a little careful about that. I think lowercase, okay, it works. Let's load it back up. There we go. Now I can do diary off. I just wanted to show how the diary worked. And then I can open it. Open it, well, there we go. It has everything I did is in the diary, including the outputs. You can't just run the diary. It records everything. It records not just the commands, it records all the outputs too. Yeah, it might get a little long. You might have to edit it down sometimes. Okay.
Wait, what I did is I just copied and pasted to Notepad. Is that good? Should I put it like that?
Well, don't put too much crap in
No,
your
yeah, I ripped everything.
homework.
Didn't work.
Right, yeah. Diary would be the same thing. You can cut and paste from your command window into Notepad, cut all the crap out, and you've got it. Diary works much the same way. You'll notice the prompts don't show up in Diary, by the way. Do I still have Diary open? I don't. There we go. The prompts the prompts are removed. And then this is just if you want just the commands, then you select the commands you want and create a script. And this is executable. If your commands work the first time, then the script is executable. So if you just want the commands, this is the way to do it. If you want everything without prompts, diary is the way to do it. And if you just want to cut and paste from the command window with the prompts, and of course the prompts inform you it's a command, not an output, but you can do that too. So there's 3 different ways with 3 different nuances of what they do. Okay. Plotting. You guys have done a little bit of plotting. There are lots of plots. So let's just go through a few of them. So I just put easy plot. I just put my expression in. What do I want to plot? Boom. Yeah, parabola. Um, let's see. There's lots of easy things. Easy contour is two-dimensional. Z equals x squared plus y squared, so it's going to look really kind of, yeah, a bunch of circles because it's a two-dimensional parabola. Yes, the middle being the lowest part. Okay. Um, Now I can't remember the difference. This will create a three-dimensional mesh. There it is. There's your three-dimensional parabola, or two-dimensional parabola. Anyway, this is the contour plot. By the way, let's go ahead. Easy mesh. A lot of times when you put C on the end of it, it'll make both a contour and a mesh. So here's your three-dimensional perspective image. We can also rotate this, so we can.
You just click down on the scroller.
So this is here. This rotate command on the figure window.
Can't you just click down on the scroller or not?
Scroller. Let's see.
Scroller on the mouse.
Nope. Nope. This is the rotation. Now you can rotate left and right, up and down. Okay. The contour, the easy contour you saw down here becomes this is the contour plot down on the bottom, matching the mesh plot on top. Okay, so that's some really easy three-dimensional things. If you have data rather than um, a formula like this, there is a contour. There's a mesh plotting algorithm as well. Um, there's another one. If you don't like the mesh, it makes this makes a mesh and a, well, it's black. It colors things. It fills things in. So surface fills things in. Mesh just leaves the mesh.
Add a C to that.
There it is. Okay. Try easy plot. Try this. And go ahead and clear X. Well, it shouldn't matter. Let's see. I did X equals 5 was way up there. It's my variable is still there and it's still working. Oh, check to see if you have a figure window. Oh, second window. Yeah, you've been plotting the whole time. It's just notice when I hover my mouse over the taskbar here, you have the Matlab window, which is this. You have the figure window, which is this. Two different windows. So watch out for that. Okay. Okay, that actually finishes chapter 3. And of course, I've gone. I kind of do an overview, ladies and gentlemen, and I do an overview. Some of the details are in the chapter, in the reading itself, and the homework. This is a good time for questions. Any questions?
When it says, like, you have your A value on the right, and it's a 5 by 5 double, what is the double?
That double is the data type, which means I think if I recall correctly, double is a 64-bit integer, or excuse me, 64-bit floating point. Um, and there's a single precision. Oh, here's a whole bunch of data types. Integers, the default, MATLAB's default is to make everything a double.
Okay, so because I was looking stuff online and I was trying to find what the hell, and it was saying a double, and I had no clue what it was
Right.
talking about.
Yeah, you can force conversion to single precision. Usually, you just want to stay with double. Most math, double is the most precise. It takes up more memory. Computers these days, I had a 20 megabit megabyte hard drive in 1984, and I thought that was really huge, and that we'd never fill it up. 20 megabytes. Um, so the uh, MATLAB just said computers are pretty powerful these days. Let's just make everything a double unless you really want something else. So unsigned integer 8. Oh, I didn't want to do that exactly. Um, there we go. Go back to double. Ew. Okay. Unsigned integer 8, 8-bit unsigned meaning no negatives, positives only. Um, integer 16, integer 32, integer 64, signed integer 8. So it's got negatives and positives. Um, you you can find out, these things can tell you the maximum of a number and the minimum possible value of a number. Um, we've already talked about matrices generating identities, ones, zeros, is floating, and these are tests. Boolean, let's see. So is not floor, float. Is matrix A a floating point? Yes, it is. True. Is it a numeric? It is numeric. It's also numeric. Um, or, okay. Um, so I'm going to test if B is a floating point. Now, I've declared B to be an integer, and it just tells me the value. It is not a floating point, but it is a number. Okay. So you can change the data type of numbers if you want. As the integers might be most useful if you've got a problem where your numbers must be integers. They can't be because of rounding errors. Floating point numbers might not exactly be 1. They might be 1 point, lots of zeros and a 1 or something like that. You might be a little off. If you make everything an integer, though, um, it gets rid of those kinds of rounding errors if you know everything's an integer. Okay. Any other questions? So double is probably what you want to stick with most of the time. Michael.
About the test, are we going to get, do you want another thumb drive for the test?
Yes, thumb drive for the test. Give me a blank one. Verify that it works, and back up your send a send it send your outputs to yourself in your email as backup. We had to do it once, and of course I can check the dates on the outputs and figure out if you're lying or not. So um, do your backup. Email yourself a backup copy. Put it on the thumb drive. Any other questions? Take advantage of the time you have because of the situation with Pirtle. Hopefully that'll get all straightened out. I think No more questions. I don't see any more questions.